Hello. In this video, I'm going to be discussing the process for creating Lewis structures for covalent compounds. So the best way for me to explain this is to go through some examples of the process, and then I think after I go through a few examples, things should be pretty clear. The first thing that we start off with is making the Lewis dot diagrams for each of these substances. And so, for instance, this first one involves carbon and hydrogen. And so carbon, if you make its Lewis dot diagram, it has 4 valence electrons, so it looks like this. Hydrogen has 1 valence electron, so it looks like that. And then you have to ask yourself, which one of these is probably going to be in the center? Carbon, having 4 valence electrons, wants to make 4 bonds. All right, hydrogen has 1 valence electron, and it wants a total of 2 to be like helium. So hydrogen only wants to make 1 bond. All right, and so if this is the case, then the carbon is the thing here that is probably going to be in the middle because it has 4 electrons that are kind of open for bonding, and it wants to have a total of 8 in the end, so it's going to make 4 bonds. So this is how this one will work. We have carbon in the middle. It has its 4 valence electrons. We've got these 4 hydrogens. We put them around the outside. So there's a hydrogen here, a hydrogen here, a hydrogen here, and a hydrogen here. All right. Notice I have placed the individual electrons on each of the hydrogens pointing toward the carbon. The reason I do this is because that electron with the hydrogen is going to be shared with the carbon. All right. And then there's going to be another set of sharing here, and another set here, and another set here. And so if you look at the electrons that exist around the carbon, including all the ones that it's sharing, it has access to 8 total electrons, which is good because that gives it the octet that it needs. If you look at the electrons around each hydrogen, there are 2 electrons around each hydrogen, which is actually good for hydrogen too, because remember, hydrogen only wants 2 valence electrons, so that it is like helium. So then the last step of this is we take those circled electrons and we make them into sticks like this, bonds, all right, and we show the Lewis structure for CH4 looks like this. All right, I'm going to do another one here. We've got NCl3. For this one, there's a nitrogen. Nitrogen has 5 valence electrons, so it looks something like this. Now, as a reminder, when we do the Lewis dot diagrams, it's not actually, there's not a specific way that it has to go in terms of which side has the pair of electrons on it versus the 3 sides that have the singular electron in it. There just needs to be one side that's got 2 electrons and 3 that have a single electron. And then like with this chlorine here, it has 7 valence electrons, so it's going to look something like this. All right, and so what we end up with then is we're going to have nitrogen in the middle. Because nitrogen has 5 valence electrons, it wants to make 3 bonds, and you can see there it has 3 spots, 3 single electrons open for bonding. The chlorines have 7 valence electrons, and they want to make 1 bond to get them up to 8, and so it has 1 spot there that's open for bonding. And so the nitrogen ends up being in the middle. If I draw the nitrogen like this, where the single electrons are on the left, right, and the bottom, then the chlorines need to go on the left, the right, and the bottom. So this chlorine is going to go here. It has 7 valence electrons. I'm going to leave its single electron pointing towards the nitrogen so that they can bond here. Then I'll put this other chlorine underneath. It has 7 valence electrons too, but this time I'm going to put the single electron on the top so that it can bond there. And then I'm going to put this last one here, and its single electron is going to go here pointing towards the nitrogen, and it's going to bond there on the side. And what we end up with here then is chlorine bonded to nitrogen, which is then the central atom here, and bonded to 2 other chlorines. The one thing that's missing in this diagram is all those extra electrons that are sitting around the nitrogens and the chlorines. So I'm going to add in here all the electrons that are not involved in the bonds. Now thinking about this and just double checking that everything is correct, A bond has 2 electrons in it. If you look at the 2 electrons circled makes a bond. And so if you look at what's around the nitrogen, we have 3 bonds around the nitrogen. 3 bonds means 6 electrons involved. All right, and then nitrogen also has that other pair of electrons on top. So we've got 6 electrons from the bond, and then its other 2 that are on top. So that means nitrogen has 8 altogether. If you look at any of the chlorines, they have 6 electrons around them in pairs. All right, there's 3 pairs of electrons around each chlorine, so that's 6 electrons. And then there's another 2 electrons in the bond. So each chlorine also has 8 electrons around it, which means that the chlorine is good in that structure as well. This next one, if you'd like to stop the video and try on your own, that might be a good idea, but otherwise I'm going to go forward with it here in a second. All right, this one involves hydrogen and chlorine. So making the Lewis structure for this, hydrogen has 1 valence electron, chlorine has 7. All right, something like that. Now, there's no real central atom in this one because there are just 2 atoms total, so you can't really be at the center of 2. So they're just 2 atoms, and they're going to be connected by a bond here. The way this goes, if we draw hydrogen like we did there, and then we're drawing the chlorine, the individual electron on the chlorine, the unpaired one out of its 7, needs to be facing towards the hydrogen so that they can bond, and then we end up with this structure for HCl. All right, HNO here, something interesting happens. We have hydrogen, which has 1 valence electron. Then we have nitrogen, which has 5 valence electrons. And then oxygen has 6 valence electrons. So what ends up happening here is the hydrogen wants to make 1 bond so it can get its 2 electrons. The nitrogen wants to make 3 bonds so it can get up to 8. And the oxygen wants to make 2 bonds so it can get up to 8 as well. Nitrogen and oxygen both want octets. Hydrogen being weird, like it only wants 2 because it wants to be like helium. All right, and so what we end up with here is that things are pretty normal at the beginning. I'm going to write this here for the nitrogen. Hydrogen wants to bond with that. All right, and it makes a bond there, and then we'll put the oxygen over here. And what's going to happen here is nitrogen and oxygen will bond, but in the end, nitrogen still wants to make 1 more bond because it has that individual electron, and right now, as it's written, there are only 7 electrons around the nitrogen. Oxygen also wants to make another bond because it's got that single electron on the bottom of its atom, all right, and it's only got 7 electrons total. And so what they decided to do is nitrogen and oxygen bond a second time here and share a second set of valence electrons. And so we get what's called a double bond here, where nitrogen and oxygen are sharing 2 pairs of electrons. And so the way that we draw this as a Lewis structure is H is bonded to N, and then that N is double bonded to the O, and it looks like this. All right, now if we count the electrons around each of them, the hydrogen only wants 2. All right, it's got this 1 bond here, so that gives it 2. Oh, see, I've missed a pair of electrons here on the nitrogen. We should have a pair up here. Because if you look at the nitrogen then, the nitrogen has 3 bonds around it. It's got the single bond, and then it's got those 2 bonds from the double bond with oxygen. So nitrogen has 3 bonds around it. That gives it 6 electrons, and then it's got the pair on top, which brings it up to 8. And then the oxygen has the 2 pairs of electrons, which is 4 total, and then it's got the 2 bonds, which is another 4. So oxygen has 8. And so everything ends up being nice and happy here. All right, well, as much as that was nice, and hopefully you got that, there are actually some exceptions to the way that some of these things go. And so, for example, the group 3A elements actually don't end up forming octets when they make covalent bonds, and I'll go through a couple examples of how that works here. So if you look at boron, boron has 3 valence electrons. All right. Hydrogen has 1 valence electron. Now, usually I ask you how many bonds something wants to make. Hydrogen would want to make 1 bond to get up to be like helium, so it's going to share 1 electron. Boron needs 5 more valence electrons to have an octet, and so boron ideally would want to make 5 bonds, but boron only has 3 electrons to bring to the table. And so what we get here is we've got our boron atom, and it's got its 3 valence electrons. And a hydrogen comes along, and boron bonds with that hydrogen. All right, and then another hydrogen comes along, and boron bonds with that hydrogen. And then another hydrogen comes along, and boron bonds with that hydrogen. And then boron is out of electrons that it can share with other things. So boron can't make any more bonds. And so what ends up happening here is boron kind of has to just settle for having 6 electrons around it. It doesn't actually achieve an octet. And so what we end up with here in this case is boron attached to 3 hydrogens, and then boron, rather than having a full octet, only has 6 total electrons. And so it's not perfect, but it's the best that boron can do. Aluminum is very similar. So this is AlOCl. So aluminum has 3 valence electrons. Oxygen has 6 valence electrons. All right, and chlorine has 7 valence electrons. All right, and so what happens here, if you think about the bonds that they're going to want to make, aluminum is going to end up making 3 bonds because it has those 3 electrons that it can bond with. Oxygen is going to make 2 bonds, and chlorine is going to make just 1 bond. And so aluminum is going to be in the center here. So I've got the aluminum in the center. We'll put its 3 electrons around it. We've got an oxygen here. The oxygen wants to bond twice, actually, with the aluminum because oxygen wants to make 2 bonds. And then this chlorine over here only wants to make 1 bond, and it will bond with the other side of the aluminum. And so what we end up with here is O, and then that's double bonded to Al, which is single bonded to Cl. And then there are extra valence electrons. So again here, aluminum is not completely happy because aluminum only has 6 valence electrons around it, but there's not much that it can do because it doesn't have any more electrons to offer up when it's trying to bond with other things. So aluminum has to kind of just be happy with 6 electrons around it instead of the 8. All right, the next one here, this is actually really weird, and I don't give you a whole lot of examples like this, but what we get is something here like SO2. This includes sulfur, which has 6 valence electrons, oxygen, which has 6 valence electrons as well. All right, and there are 2 oxygens. Now, some people end up thinking, okay, they're like, all right, I've got everything here wants to make 2 bonds. The sulfur wants to make 2 bonds, and the oxygens want to make 2 bonds. And if you line them all up, you actually can't make it work out that way. Some people say, oh, okay, I got this. What we'll do is we'll have a sulfur, and it will bond to an oxygen, and then that will bond to another oxygen, and then it will bond back to the sulfur, right? And we get something that looks like this. All right. Unfortunately, this doesn't work out because of something that's called angle strain. These bonds forming in this way, they create an angle between the bonds, which is actually very, very unstable. It's a really, really tight angle. And so things don't make little triangles like this. That's just not something that happens in chemistry. And so what we get, I'm going to put sulfur in the center here. And sulfur has its electrons. And there's an oxygen on this side. And so what happens here is the sulfur will bond with this oxygen, right? And then we've got this other oxygen over here. And it will want to bond here as well. All right. But things end up not working out very well. And so what happens is things end up swapping electrons a little bit here. Now you have to have the same number still. But what ends up happening is this sulfur here, for instance, can give one of its electrons to the oxygen. And so it'll say, give this electron here over to this oxygen. And what we end up with is something where this is transferred. All right, and so we have one more extra electron around that oxygen and one fewer electron here around the sulfur. And what that allows sulfur to do is make a second bond here. And then if you look, we just took one electron and transferred it from the sulfur to one of the oxygens, but that makes it so everything actually works out in terms of the octets. If you look at the oxygen, it has 8 electrons around it for both of the oxygens, and the sulfur has 8 electrons around it, and we have the same total number of electrons. It's kind of weird. So we've got this oxygen. This oxygen is the normal one. It has 2 bonds, and it bonds with the sulfur, right? But then this sulfur acts more like a nitrogen because it gave up one of its electrons and is bonded to this oxygen. And this oxygen acts more like a chlorine because it gained an extra electron. And this is what our final structure ends up looking like. Carbon monoxide is a similar one. In fact, maybe this is kind of an easier example. And so we've got carbon, which has 4 valence electrons around it, and we have oxygen, which has 6 valence electrons around it. They bond to each other once, all right, and that's good. And then they bond to each other a second time, all right, and that works out as well. But then we have this situation where the oxygen is kind of okay, but unfortunately the carbon is not okay. And so what ends up happening is this oxygen is going to give one of its electrons to the carbon, which I'll put over here. All right, and then they can bond a third time on the top. And so what you end up with here is carbon bonding to, triple bonding here to an oxygen. All right, and then there is a pair of electrons around the outside. So this is carbon monoxide. It's something that we know that it exists. It's actually, these things, if you're thinking they're weird, they're not particularly stable compounds, but they do form in nature. And so these things where the electrons are getting shifted around, they're not normal substances, and they're, as I said, they're not as stable as the other ones that we were doing on the top of this page, but they do exist, and so I want you to know how to do the Lewis structures for them, and so this is kind of what we end up with here on this. All right, so I have a whole series of practice problems that we're going to do on these. You've got hydrogen and 2 hydrogens and an oxygen here, so hydrogen looks like this. All right, oxygen looks like this. If we have this set up, oxygen's going to be in the middle because it can make more bonds. So we've got the hydrogen and an oxygen, and then the other hydrogen. Oops. All right. All right, sorry, the oxygen looks like that. And then is going to bond here and here. And we end up with something that looks like this. Now on this one, you might actually have a shape that looks like and that's acceptable as well. All right, either of these are acceptable. I'm just going to go ahead and keep it the way that I did it because I put the open electrons for oxygen on the left and bottom side, so that's where the hydrogens are going to go. But you could have put it the other way as well. So that's what that one looks like. For pH3, and P has 5 valence electrons, H has 1 valence electron, and so what we'll have here is a P in the center. It's open for 3 bonds. There's going to be a hydrogen on this side, hydrogen on the bottom, hydrogen on the side here. All right, and so what we end up with on this one is P in the middle, 3 H's around it, and don't forget to put your pair of electrons on that. All right, carbon dioxide. So we've got carbon, which has 4 valence electrons, wants to make 4 bonds, and then we've got 2 oxygens. Each oxygen has 6 valence electrons and wants to make 2 bonds. And so the carbon making more bonds is going to go in the center here. So carbon is in the center. It has its 4 valence electrons. We have an oxygen here. I'm going to leave the top and the right spots open here on the oxygen for bonding, so we get bonds formed there. Then I'll put this oxygen here. On this one, I'm going to end up putting the open ones on the bottom and left for the oxygen because we want to leave spots for it to bond this way. All right, and then what we end up with here is oxygen double bonding to the carbon, which double bonds to another oxygen. And it looks like that. HBr, H has one valence electron, wants to make one bond. Bromine has 7 valence electrons, wants to make one bond. And so what we end up with here, we've got the H is valence electrons. The bromine, you're going to put the single one facing towards the hydrogen so that they can bond that way. And then we end up with just HBr here. And then you have to put those electrons around the outside to get that one to work. H2CO, all right, so in this one we've got hydrogens, those want to make one bond. We've got carbons, those want to make 4 bonds. All right, 4 valence electrons. Oxygen has 6 valence electrons, wants to make 2 bonds. And so the way this works, there are 2 hydrogens, so I'm going to draw my carbon here. Draw a hydrogen on one side of it, it's going to make a bond there, another hydrogen here, make a bond there, and then on this oxygen, I'm going to leave the left and bottom sides open because it's going to need to make a double bond here with this carbon. All right, and what we end up with here then is C bonded to the H, bonded to another H, and then double bonded to the oxygen, and then with our electrons there on the oxygen. All right, this next one, C2H2. And so this one, there's not like one atom that's in the center. So I told you there's like multiple central atoms. And so what we end up with here is carbon, which has 4, right? And then we have hydrogen, which has 1. And so we're going to put the carbon in the center. All right, and then it's actually going to be close to another carbon. And then we're going to put the 2 hydrogens on the outside. So I'll put a hydrogen here. I'll put a hydrogen here. All right. The hydrogens bond with the carbons, all right, and then the carbons bond with each other, and they actually end up bonding with each other 3 times to form a triple bond. All right, so we end up with H and then C and then triple bond to a C and then another H on the other side. Okay, this next one, getting really complicated. We've got 2 carbons here, 5 hydrogens, an oxygen and another hydrogen. So this OH, I had mentioned it in a set of notes before, that indicates that we're dealing with an alcohol. And if you've got OH at the end of it, the O and the H are often going to be connected to one another, just as a little bit of a hint. So we've got carbons in here, which have 4. We've got hydrogens in here, which have 1. All right, and we have oxygens, which have 6. The way this is going to work, and again, this has multiple central atoms. There's going to be a C, 4 electrons around it. And actually, I'm going to try and draw this a little bit smaller because otherwise I know that I'm not going to be able to fit it. So we've got a C with 4 electrons around it. Then we've got a hydrogen. There's an electron there. I'm going to put another hydrogen here. All right. Another hydrogen down here. Okay, then we have another carbon here because we've got 2 carbons in this structure. Put that carbon there. There's going to be a hydrogen down here, a hydrogen up here. All right, so now we're up to 5 hydrogens. And then this OH together, we end up having an oxygen here with its 6 valence electrons. And then I'm going to put another hydrogen over here on the other side. Okay, and so the bonds that we end up forming is we form a bond here between that carbon and hydrogen, there between carbon and hydrogen, here between carbon and hydrogen, here between the 2 carbons, here between carbon and hydrogen, here between carbon and hydrogen, here between carbon and oxygen, and then here between oxygen and hydrogen. So the structure, how it ends up, is we've got H bonded to C, and then another H up here, and then an H down here, and then another carbon, and then an H, and an H, and then an O, and then the H, and then those. So there are some various shapes that this could take on, but it should have the same general structure. Two carbons in the middle attached to an oxygen, which is then attached to a hydrogen, and then hydrogens around all the other sides. So that's what that one looks like. HbCl2. Okay, this one has boron in it, which boron is one of those weird ones that has exceptions. And so we've got a hydrogen, which has 1 valence electron. We've got boron, which has 3 valence electrons but can only make 3 bonds. All right, and then chlorine, which has 7 valence electrons. Oops, that's chlorine. I'm going to rewrite that. Chlorine, which has 7 valence electrons and wants to make 1 bond. Okay, so what we end up with here then, there are 2 chlorines in this. So we've got the boron in the center because it still wants to make the most bonds out of anything. It wants to make 3. We've got the hydrogen here. It's going to attach, and then 2 chlorines, so bond there. All right, and then the thing here is, again, that boron is just not very happy in the end because it doesn't have an octet, but it just has to deal with that. That's the way that things go for boron. So we got boron attached to chlorine, attached to chlorine, attached to hydrogen, and then each of these chlorines should have electrons around the outside. Alrighty. Getting near the end here, we've got HCN. This hydrogen wants to make 1 bond. Carbon wants to make 4 bonds. Nitrogen wants to make 3 bonds. All right, and so hopefully you can kind of see the logical structure here. Hydrogen is going to bond to one side of this carbon. All right, and then the nitrogen, which wants to make 3 bonds, is actually going to end up triple bonding to this carbon. All right, so that they end up having octets, and so that when we have H bonded to C, which is triple bonded to the N, and then there's another pair of electrons out there. And that's what we end up getting. All right, N2O. N2O is one of those weird ones where we're going to get, it's going to have electrons kind of being transferred from one to another. And so what we get here is we've got 2 N's. N's want to make, N's have 5 valence electrons, or 5 valence electrons want to make 3 bonds. Then we've got an oxygen in here. It's got 6 valence electrons. It wants to make 2 bonds. And so what ends up happening here, we'll put the N, one of the N's in the middle because 3 bonds, so more than the oxygens. All right, and then I'll put an oxygen here. All right. And so, and there's this pair of electrons up here. And so what ends up happening here is then we bring this other nitrogen in here, and it wants to bond as well. And what we get is it can bond once here, right? But then things are kind of not working out, right? We have this last nitrogen, it wants to bond one more time, and things aren't working here. So what ends up happening is this nitrogen is going to give up one of its electrons, all right, and give it to that other nitrogen, and then they can bond up here. All right, and then we have nitrogen double bonding to nitrogen, which double bonds to oxygen, all right. And then this one here looks like that, and then like that. And again, these are like pretty weird structures, but this is what we end up getting. So the oxygen is normal, but one of those nitrogen acts kind of like a carbon, the other one acts kind of like an oxygen, and it has to do with the way that the electrons are transferred between them. So yeah, watch out for those weird screwy ones. They're not very stable, but what you'll find is you're trying to make them work, and you can't find anything that works out, and what ends up happening then is you need to get a transfer of one electron from one thing to the other, and then they can bond together. So sorry about those ones. They'll creep in there every once in a while, but mostly they should be pretty easy.